Okay, hello everyone. My name is Liang Yan. I'm a software engineer from Colville. Yeah, today I'm going to share a journey. We are trying to optimize it's actually the peer-to-peer DMA things there, even though this is based on a NVIDIA stack. And the limitation we met between here from software side and hardware side. And just we thought we found a solution to their H100 system, but then we hit to the GH200, a totally different architecture. So we'll see the details later here. So yeah, today we're going to look at this here. So I think before, yeah, just like I said, the motivation here is simple. We have a quite a limited timeline there. We try to get the best performance for the GPU to network card, go to the other network card, and go to the GPU. So basically the GDRDMA there. And the performance is really bad at the first look. But then we saw it from software side, hardware side, and then we get a better results there. But we do see there's some limitation, lacking of flexibility. And then also comes to some GH200. Yeah, I think before start, we can have some quick background here. I think we are all of the experts here, so this should be quick. The test, we are using the RDMA perfect test. So we are using the IP write. We choose write because we are more focused on the GPU stuff. So the nickel, actually the write is more fit for the nickel test there. And yeah, some terms, tech terms we met here. GPU RDMA, I already talked a little bit. And there's ACS, ATS from the PCIe term, and IOMMU, of course. So yeah, just like I said, the direct RDMA. Without that, we know all the device memory need to go to the system memory to pin and then to communication with each other. Direct RDMA is actually like here, the network card is when allocate the memory from network card. It's actually using the memory allocated from the GPU, the base address there. So basically all the address here is GPU address. So GPU memory goes to the network card cache if they're using, and then goes to the cable and go to the other side. Finally go to the GPU memory. Mm-hmm. Yeah, I put the ACS and ATS here just because they're so similar, but they are quite different stuff here. ACS is more like a PCIe, it's more like a protocol, a PCIe capability there. So it could control the connection between the PCIe enterprise endpoint to the other one. So you can decide control it, excuse me, if they could redirect, block or something. ATS, the other side, is quite familiar with us. It's more like a TRB to the device rather than it's more like ATS to device is more like the TRB to system memory. So it's more like a cache system, saves the page table, the physical page table mapping to the system page table to the physical address there. So this is actually quite important in all the system. Because we know that TRB saves a lot of the performance from the main system. ATS is also doing the same thing here in the IOMMU. We can see that later. So, and yes, IOMMU. I think this is quite familiar. So we actually try to isolate the device, make it more safe, more independent. This is very important tag to the cloud scenario, even mostly in the virtualization, but I think people are more notice it from a containerization scenario. So yeah, here's the beginning. So yeah, during our test, we are using Mellanox CX7. So the physical speed would be 400 gigabit. So yeah, so we are trying to hit this limited line as much as possible. However, it's so frustrating at the first place. If you see that we actually only get 85, and with ACS, after we disable ACS. So enable ACS, disable ACS is more like we could allow the device could communicate with each other, peer-to-peer DMA. Otherwise, it will need all goes to the PCIe switch. If there is a downstream port, goes to the conflict there, and get the address and come back. So it's a long detour there. Yeah, we see it frustrating because it's even worse than the device P2P connect without not under the same PCIe switch. It's like even if we see the device, they connect under the same NUMA, not the PCIe switch, it's actually much faster. It's 255 there. And even we cross the UPI, goes to the other NUMA, it's even faster. It's 250. So the direct response feedback to us is that this is definitely something wrong with the PCIe switch. Like why the shortest path has the slowest speed there. The later also confirmed this conclusion. And yes, this is because like the hardware perspective side. Yeah, we can go there. So later that we also after we contact with the vendor there, we actually using two different vendors there. As you know, for the AI, for the GPU, HPC machine server there's not so many vendors. Dell, SMC, and even that CT system, which is just acquired by AMD there. But there's still a slight hardware difference there. For this one, of course, it's not good to the hardware. It's not good to the PCIe topology, like the general hardware. It's more good to the PCIe switch. So yeah, we can just see the data here. So first we updated the PCIe switch there, and we did get the improvement, but only for bare metal system here there. So if you see, the bare metal could reach to the near the limit there, 400. It's very well. Of course, it's with the disable ACS, which means allowed the PCI peer-to-peer. However, when it goes to the virtualization, we know in virtualization, we definitely need to IOMMU-regroup there. So there's a DMA remapping there. There's an address translation. We thought that this is the issue, but we couldn't identify. So it turned out also some kind of hardware issue, but we can get that later. So do you want to go to yes, I'll go there. Okay, yeah.
You can't run virtualization and turn off ACS and really expect it to work unless you do a whole bunch of special stuff to expose the actual physical addresses and physical topology to the VM, because it's not virtualized anymore once you turn ACS off.
We can. I go that there's a portion about that one. I think we can get into the virtualization without IOMMU. Like I said, for ACS, ACS is more like a PCI device there. You can enable it, you can disable it, it's still, but with IOMMU there, because after you enable ATS, actually, ATS, there's override to ACS. So when you enable ATS, or you see you want to enable ATS, you need to enable P2P translate bits there. This bit is actually override the P2P redirect and the ingress control, ingress bit there. So I would see at some point you're right there. Like even if you enable ACS there, it's kind of being disabled, override by the ATS bit there.
Right. Translated requests have different routing rules than non-translated requests because they have different requirements. I'm just saying, like, if you disable ACS and try and run a VM, the addresses in the VM are not going to match the physical addresses, and it's not going to work the way you expect. And that's why you're getting these weird performance numbers, because you're still going through the IOMMU because you're not using the physical address that would go direct anymore, because your virtualization has got the wrong address in it.
ACS is not about the
I think he's saying, though, that he's enabling the direct translation in the ACS capability,
Yeah.
which should allow the redirect at the closest switch
It doesn't matter if the address is wrong.
if they're using ATS.
Yes.
Are these with ATS turned on?
Yes, I'll go to there. So you are very ahead of my topic here. You're thinking very. So this is this is actually an issue with ATS. Like ATS is kind of a preventer. So for CX7 they just announced this feature. It's quite new. It's not right. So once we update the firmware there, the ATS works as normal. We could get a better, when it goes to the conclusion side, I'll show you, we could get very good results. So eventually this is more like, I think, like I still insist my perspective here. The ACS is not about the address at all. It's just about how to control the device connection in the PCIe bus.
True. ACS interacts with the switch routing registers, like the bar registers and the routes in the switches interact with the ACS bits to decide where to send the packets. So if you send an address that's not going to be matched by the decoders in the switch, it's still routed to the host bridge. And that's what happens in virtualization. You put addresses on the bus that don't match the decoder windows because the virtual bars inside your VM don't match the physical decoders, and it still goes to the IOMMU anyway. And effectively, your ACS doesn't get a chance to go on the direct path because your address is wrong. Like that's when you don't have ATS involved. That's why ACS doesn't help you when you turn on the VM, unless you're very, very careful in how you construct your VM's address map.
Yeah, yes, that's thought. We thought we enabled ATS there because when you CX7 card there, there's only one option you could do that. Even you couldn't set in the firmware. We enable the ATS from the MS configure. So you're right. At this moment, the story is not finished yet. So, but like I said, when you enable the ATS, it's actually override the ACS, even if you enable it or disable it.
Well, it uses different enforcement rules because its translated requests use different enforcement rules from non-translated.
Yes, I also go. This is also comes to us a concern, like because when we enable ATS, there's still it is still needed to enable the P2P translated there. There's still a security concern there. So we are thinking like, even we have the ATS, we have the ACS, maybe we, but because ACS is not that flexible, it needs to either it's a root port or a up port of the PCIe switch. So it doesn't work like if it's a portion of the downstream part of a PCIe switch. So we actually want some more flexible for all of the ACS there. So, but I agree that you said the ACS is partial for the virtualization scenario. It's just overwritten by the ATS there. Somehow, so it's still you can still that we still kind of disabled it in a VM with ATS. Does it make sense to you?
I mean, our expectation with these solutions is that you'll run ATS for your VMs. Like that's the recommendation.
Yes. The time is we can
It
talk
sounds like you
offline.
have more.
Yes, we can talk
move on.
offline
Yeah,
there. I think
move
that's a very
on.
good question. So, yes. So, like I said, so PCIe topology there, we have the Dell SMC. We're looking. It's a little bit different. For example, like I talked about like the ACS control range there. It could only works for the ACS, the root part, and also some up part of the PCIe switch there. So which means if you put multiple devices in one under the same PCIe switch, you need to kind of assign the same IOMMU-regroup to it. However, this is not true in a cloud scenario. Sometimes we may want, like for example, we bound the GPU in the PCIe switch and the CX7. We actually also the NVMe there, controller there. The different part of the Dell is that they also put some non-CX7, the CX7 we are using for the GPU fabric, and there's also the network for the management network there. They also bind to one of the PCIe switches there, which caused that we can't totally isolate the device there. So we want a case that even they are under the same PCIe switch, we kind of want to just pass through partial of the device there. That's we kind of do in the current, all the current kernel or development here.
Well, no, you're supposed to turn on ACS. You're supposed to turn on ATS and set ACS enforcement so you get discrete groups. And that's how the solution is supposed to work when used virtualization. That's the only option that satisfies all of the requirements.
Yes, that's what I said. But this is, we do even do that, thinking you have multiple devices under the same PCIe switch. You enable it, you kind of disable, enforce it, you enable ACS there, but it's not really working. It's part of it, and when you enable the ATS there, it could still like a P2P it could still pass to, no matter you enable the P2P direct or the egress control there, they could still like using the, once the address translated, the AT is confirmed from there. So it could still being transferred to the other device. This is kind of a behavior similar without similar with the disable ACS there.
Yes, that's why it's a recommended solution. You turn on ATS, you get the translated bit, it goes peer-to-peer, you get multiple IOMM groups, and you still get all your security. Yeah, this is the correct thing to do.
Yes, but we can't get, like for this same device there, we can't get multiple IOMMU there.
Why not?
Once you under the same PCIe switch, it will all bound to the same the same group.
You turn on ACS and you'll get multiple groups.
Yeah, but we don't want this case. We want to put some, yeah. Yes, because we want a second layer security there. With ACS, I think, yeah, from the software side, because of the ACS, IOMMU could, because, yeah, your question is a little bit, because from here, I did talk something about this part issue. I'll come, we can go there, okay? Huh? Okay. We let's talk. I think you have a very good question here. So, yeah.
So did you come up with a solution that satisfied what you wanted?
Here.
Okay. Why don't we talk to that?
So is this what you discussed?
This is what you're supposed to do. Yeah.
Yeah. But we said we still have limitation out of this here. We still couldn't like. I think, yeah. That's why I understand your question. We cannot that. But let's see our limitation here. So if we kind of want to like because ATS there, they will have a different group there, but it's actually, even if they are actually in different group, they actually still could connect with each other.
Well, no. I mean, according to the defined IOMMU and VFIO security model, they can't, because we're trusting that the ATS mechanism is trusted. Like that's the security model of PCI.
Yeah, ATS is based on the trust address there, but you can still have the. But we are thinking like if we could, because this is also include. I can go to this part. I think for this part, yes, with this solution we could get the best results, but we have some limitation there because we put some device, because of the vendor difference there. Sometimes they put all the device under the same PCIe switch. We want like if we could totally enable it, the real enable, there's no override there. We want to add another layer of the IOMMU group there. This is just the theory. We haven't do that. I think maybe we'll hit the issue you mentioned before. But so actually when we come to the GH200 there, so the situation is a little bit more different, it's because because from this area, it looks more similar to the CXL memory actually. So for example, for the current GH200 scenario, we saw because of the NVLink C2C, so the system memory and the device memory, they are actually they are actually in a unified virtual memory address there. But if you see the CX, they put a CX7 there, but actually it's not actually under the same PCIe switch with the not CX7, it's a DPU anymore.
So I guess we're running out of time, but on the system you're talking about here, there's no need for a PCI switch or a peer-to-peer path because the underlying C2C and everything else has more than enough bandwidth to do what you want to do. So it's very simple. You just use the IOMMU, don't worry about ACS, and there's no problems.
This is not only about that, this is also, I'm talking that is actually, I'm thinking for this here, like if you enable that, you could see it's more like CPU-less NUMA node there now. So there's no NUMA per GPU node there because, but it still have the NUMA for the NVLink connection there. So if you enable a kernel there, you could see there's still non-NUMA group there. That's weird, but the system memory and the local GPU memory is under the same NUMA, but there's still some memory from other device. So this is very like the CXL memory there, the memory tiering. But a little different is that here the memory is actually faster than the system memory. So it's HBM, and the CXL memory it's much faster. That's why they put a scalable coherency fabric there. So in general, I think so. Yeah, for this is a little bit transfer from the current IOMMU issue here. From here is more like how do we do the device memory, especially the fast device memory there, like the GPU memory, HBM. I think there will be more and more other memory in the future suit up similar here. This would be more like it would be more. I think it would be more similar with the CXL or the HMM there, and they will do make the IOMMU is more similar with the MMU, and so like using the PRS. So you don't need the pen, and all the behavior would be more similar, like even it's a device memory or a system memory there. So this is totally new. I think the current IOMMU is a little bit different. But like I said, this is just the beginning. We just get the GH200 there.
Liang, I need to ask you to wrap up. Do you have any last question for the audience? Or, perfect timing.
Okay.
I mean, there is a raised. I know that there is a raised hand. Gu, I'm sorry, but I think we can take it offline. I'm sorry, but we need to keep on going because otherwise we will be running late. Otherwise, so any questions? Last.
Yeah, I think I would more like because when I'm working on, especially, first is like. I think it also partly related to the question he asked, because I'm also a question like, can we do the future like if we regroup from the IOMMU? I didn't see the API from the IOMMU-FD, but is it possible like we could regroup the? I know with the ATS you don't need it to, but if we want to do that, is it feasible to still kind of no? Then the second question is goes to the, I think, sorry about that. It goes to the GH200 there for CXL memory there. So I think so far it's all about because the GPU memory is a little bit different from other device memory. We actually, when we saw the P2P DMA there, we saw this issue here. the device memory is not maintained by the page. It has like especially for the GPU, it has its own TTM management system. So we are thinking like if make it more look at the device is it possible to make it more look at device memory similar with the system memory, like a page allocation, page management? I saw there's some legacy patches there, but a while ago. So I'm curious, what's the latest the trend for development or research on this area? More mixed device memory or GPU memory, more like system memory.
We'll have to take it offline, but thank you very much
Yes,
for your
yes.
session.
Okay, thank you.